Welcome to the meetup for the 31st. Got a jam-packed day for today. So to make up for last time, I thought we could do something quite interesting today. So I was going to introduce to you forecasting. A book that I'll want to share with you is Economic and Business Forecasting by John Sylvia and Professor Iqbal, Azir Iqbal. So the last week we talked about Colorado data, and so there's been a lot of talk about what may happen in 2021. So we're going to build a forecasting model. So first, we need to take into consideration that we need to maybe have a set in stone methodology for forecasting. So we're going to follow these 10 steps. Number one, we need to know what we're forecasting. Number two, we need to understand the purpose of forecasting. We need to acknowledge the cost of forecasting. We need to rationalize the horizon. We need to know what variables we're using. We need to know what forecasting model we're using. We then need to know how to present the results. We need to know how to decipher the results. We need to iterate over time using recursive methods. So we need to not just leave this, we need to keep working with it. And then we need to understand that the model may evolve over time. So we may figure out new and better ways to forecast. We'll actually come back to the statistics here in a bit. So sorry for the rocky introduction, but we'll just go ahead and start here. So knowing what we're going to forecast. So we've been working with the data in Colorado. So last week we showed how given sales and plants, we were able to calculate a production function for Colorado, and we were able to estimate a competitive wage and the real rate of capital in Colorado. So those were historic. So if you wanted to set wages or invest in 2021, it would be useful to know what you could expect the minimum wage or the competitive wage and the rate of return of capital to be. So that will bring us to step two, understanding the purpose of forecasting to get better expectations for the size of the Colorado cannabis industry in 2021. Let me pause real quick and get my coffee, and then we'll move on to step three. All right. So, after all, we're doing tea, so here's to an awesome day. All right. So, bearing with me, we're now going to understand the forecasting error. So, after all, we're using this to predict the number of plants and the number of sales. So, if we overstate, we may lead to foolhardy decisions. But if we understate, we may leave money on the table. We're just going to rationalize the forecasting horizon. So we're just going to estimate 2021. We think 2021 should be informative. Any time frame less than that, it may not be worthwhile. And then any longer time frame, we start to lose credibility in our forecasts. It may be worthwhile to forecast 2022. Anything beyond 2022, you start to have a good bit of skeptic. You start to approach with a good lens of skepticality. Next, we want to understand our choice of variables. We're simply going to be using sales and plants. And under the principle of never throwing away data, we're going to be using the time frame of January 2014 through June of 2020. Now, to introduce the forecasting model, we've been working with regressions. So this is actually an atheoretical model that utilizes your standard regression model. So we're essentially saying that sales or plants in time period T depend on sales in T minus 1, and they may depend on sales in T minus 2, all the way up to a certain period. So this is not theoretical, but it's a useful way of modeling data. And it actually can be quite useful for forecasting. And then the moving average process is essentially saying that the error also depends on errors from prior periods. And we'll approach that with our statistical model. As always, we'll want to show the data. The best way to do that, if you know of Edward Tufte, is a figure. Then we'll want to look at the forecasting results. We'll want to look for seasonality. We may want to look at the totals. So anything of interest. Of course, you want to use recursive methods. So after we make our forecasts in several months' time, we'll want to come back and double check the forecasts, see how far they were off, and perhaps make new forecasts for the coming year. So perhaps in 6 months' time, we can double check the forecasts, see how far we were off, and try to do better next time. And that leads us into principle 10, understanding that the forecasting models will evolve over time. For example, we may see that there's seasonality and think of ways to control for seasonality or introduce seasonal effects. So there's a quick, dirty presentation. And so now let's go ahead and jump into the data. So So we are working with the same data set we worked with 2 weeks ago. This data that we've collected from the Colorado reports. These are quarterly reports. So currently we only have data through June of 2020. But we have data on the number of people working. We have the number of plants. We have total revenue. We have some interesting metrics here. So first things first, we're going to go ahead and use our good friends pandas. And we're going to read in the data. Always look at the data. Look sound. And so now I'll introduce you to a forecasting model that I wrote several years ago. So we are essentially using ARIMA from stats model. And ARIMA will calculate this model for us. So we're essentially estimating an ARP plus an, right? So we're estimating essentially an ARMA. P Q. So we're essentially combining these two processes. Sorry for that dirty writing. How are we going to pick the best model? Well, this is where I wanted to introduce to you the concept of root mean squared error. So here, we take our actual minus the predicted. And you would sum that over all of the periods where you've made predictions and you have actual events. Well, how do we have predictions if we don't have actuals? Or, I mean, how do we calculate a root mean squared prediction if we don't have predictions? So essentially, we're going to utilize a holdout period. So here we're going to have a holdout period of a certain amount of months. So looking at this data, it's relatively arbitrary, but I think a holdout period of 6 months maybe a interesting span of time. So you could essentially use all of the data up to December of 2019 and then forecast the first 6 months of 2020. And then whichever model forecasts the first 6 months the best, you'll then use that model to then go ahead and predict all the way, through through December of 2021. So we're going to make forecasts for the next 18 months. So just to kind of give you a brief of this code, just to kind of show you what's going on under the hood. Nothing fancy. Essentially, we're just taking a time series. We're separating it into a training period and a testing period. And then that's just going to be by the holdout period. Then we're essentially going to scan ARMA's P and Q. So if you go back to the presentation, you'll see that P and Q are arbitrary. So you can have an arbitrary number of regressors, auto-regressive regressors, and you can have however many moving average regressors. So we can't calculate an infinite number of models, so we're going to limit our scope of models. So we're essentially going to limit the lag order to perhaps 6. So we're essentially, you could do more. This morning I tried it with 12 and it just wouldn't estimate. So the more data you have, you can typically use longer processes, but you can also use some rationality, and you may not want observations from that long ago using to predict what's happening in period T. So you can use a mix of common sense plus what actually forecasts the best. So we're going to limit our scan of ARMA models to 6. So now we're basically just going to loop, and we're just going to say, okay, so now so for P, for Q, we essentially just create an ARIMA model. And this is actually does a rolling forecast where you'll use your forecast to go ahead and predict a new model in each iteration. Once you've estimated a ARIMA model for each PQ combination, so keeping in mind that if the model will not fit, so even if you're only doing it to 6 lags, if it still is an unstable model, then we're essentially ignoring it. So we're just ignoring unstable models. and keeping the forecasts and the root mean squared errors of successfully fit models. Using the root mean squared error of the handful of ARIMA PQs we estimated, right? So we're basically estimating right, so we're essentially estimating, right, like an ARIMA like 0, 0, 1. Well, let's just think of it as ARMA. Like 0, 1, like ARMA 0, 2. You know, ARMA 1, 0, ARMA 2, 0, ARMA 1, 1, so on and so forth. You're then going to see which of these models predicts these variables the best. So does the ARMA 0, 1, does the ARMA 0, 2, does the ARMA 1, 0? Which one of these predicts total revenue the best for our holdout period? And then we'll select that model to go ahead and predict the next 18 months. So we've identified the minimum root mean squared error. And then we're going to use that model to predict the forecast period. So
is this like a grid search?
It is. It's essentially, it is a grid search. It's and you could make it more complex. You know, this is just scratching the surface of what you can do. So this is what you would call an auto ARIMA, or an auto. Well, this isn't even an ARIMA. This is an ARMA. So this is an auto ARMA. So you're essentially scanning. You're doing a grid search of a handful of models, and then picking the best one. So just to kind of, so that's the logic. Now to abstract it away and actually use it. So we're going to be using a lag order of 6. We're going to be using the 6 holdout periods. And then we're going to forecast 18 periods ahead. So I wonder if we could print out. Oh, let's just let it run. All right. So here we go. So see here we're fitting a bunch of different models. You'll see that this maximum likelihood. So the model is being fit by maximum likelihood. So you're seeing some error statements being printed out when the model fails to converge. And that'll happen if you essentially overfit the model. So if you try to pack in too many regressors. So for what they call high order ARMAs, So like an ARMA 6.6 with very little data would likely fail to convert. And so see here, we're getting into these higher order ARIMAs, like ARIMA 4.6 failed to converge. So it looks like these higher order ARIMAs are mostly failing. So well, and here's our final ARIMA 6.6. Looks like it's having a little difficulties. All right, and so after all that rigmarole, we got our best model as an ARIMA 4.6. Well, an ARMA 4.6. So we're basically saying that we think that there are 4 autoregressive terms and 6 moving average terms or regressors. And rule number 1, show the data. So here is essentially our forecast for the next 18 months. So I wonder if we can add an index on this real quick, so it'll be a bit more informative. Well, that's maybe not the best way to do it. Let's see how to create a quick.
Yeah, there is a really slick pandas way to do this, but I can't tell you off the top of my head. I'm not that familiar either.
Ooh, anywho, that's essentially brings us to knowing how to present the results. So now we need to get this into a decent looking figure.
Okay, but so is this so this is like an ensemble? You have a series of regressors, right? And so you're coming up with a final result using a series of regressors and then like a weighted average of them. So it's kind of like or you're weighting them. So this is like an ensemble of regressors.
So here, just to show you a bit more detail of what's going on here. So now that we've decided, okay, this ARIMA 4.6 is the best model. Let me just show you what an ARIMA is. I think I think that would be a lightning. This is a 4, 0. Right, so let's see if we can't fit this model real quick. So then you can print model.summary. Well, maybe not. Okay, so this is essentially the regression that we ran. So we have 78 observations. We have a constant. We then have 4 of these moving average, of these autoregressive terms. And these are their coefficients. So you see a positive coefficient on beta 1. So that would indicate higher sales in the previous period would lead to higher sales in period T. However, you can't really remember the Box-Jenkins methodology is atheoretical. So you really can't put too much interpretation on these coefficients. But essentially what you have here are your 4 autoregressive terms, and you have your 6 moving average terms. And I can maybe send you some material on how to calculate the moving averages. It's it's a little bit more involved, but it's so I'll want to get some material on moving averages and add those to the repository for you. Do you still have, does that answer your question, or do you still have the question?
Yeah, no, I see what's going on. I mean, it's sort of like, it's actually more like a neural network where the output it's a weighted sum of these outputs, right? These autoregressors.
You could think of it. You could think of it that way. If you want to think of beta as your weight, but keep in mind, it's almost more of like a magnitude versus a weight, right? Because so some of these may have negative coefficients. Right, because if it was just weighted, then they would all have a positive effect. But some of these may have a negative effect, some may have a positive effect. Some may have a small, some may have a large effect.
Okay, yeah, I get the gist of what's going on. So.
Look, that's awesome. And so this is, it's a little bit of an ad hoc way to forecast, but you know, as you saw, oh, whoops, I'm just fitting this whole thing again. Ooh, well, here, let's just do the same thing, but maybe with plants to a smaller. Here, yeah, in the remaining time, why don't we just do it with plants and then add the time series so we can actually interpret our results. Because we still have a good 15 minutes left. So, okay, so now let's rinse and repeat. Let's reduce the lag order to 3 just to make things more manageable. And then while we're doing that, I'm going to do a quick Google search for how we can add a two things. One, we need to add time index to a pandas series. And then 2, we need to create, you know, time series between, you know, 2 points. And see if there's not any good solutions. Okay, so that's not what we want. Bear with me, but this is this is how you get. This is how the sausage gets made sometimes. Right. So we'll do total revenue for the time being, and I'll refactor this at a later point. So,
Yeah, you have to make like a list of the dates that you want as the index, and then when you create the series, use that list. Tell it to use that list as the index, but I can't tell you like the exact syntax off the top of my head. I would it's something I would have to look up too. But
it's one of those things where I think I've coded it up before, but instead of digging for an old snippet, I think I'm going to see if we can't just code this up real quick. So apologize for making you bear through this.
oh no, that's fine. I do this all the time.
So see if we can't, because we're just trying to go until 2022 essentially. Let's see if. Okay, that actually looks like the index we want. So I wonder if we can just do Okay, not so painful after all. See, this is why Pandas is just a beauty to work with. So now we've, just in a matter of 5 minutes, we added the time index on there. So now we can actually move on to, so now we actually have presented the data in a fairly acceptable manner. So now we can actually decipher the forecasting results. So we're essentially forecasting, it looks like monthly sales. I want to say that here, I guess we could maybe even plot this. I wonder if we could plot this in millions. Okay, awesome. So now I've essentially plotted this in millions of cannabis sales. So you'll see that we forecasted sales will dip down in October and January to about 165 million a month, and then increase during the summer and peak at around $195 million a month in Colorado in July, June and July. So that is, quite a lot of revenue. And so just to remember, so if we hold out the first 6 months, because that's 2020, you're looking at about $2 billion worth of sales forecasted in Colorado in 2021. So that's, so that's how we essentially, we'll want to now use recursive methods. So now, hold me to that. So now, mark my words on, March 31st, 2021, we predicted that in 2021, so we're looking into the future, we're predicting that there's going to be $2.1 billion worth of sales in Colorado in 2021. So now, we play the waiting game. So now we'll wait, and as this data comes out, we can double check our forecasts, and we can wait till the year's over, plus time for them to get the data out, and we can see if, this $2.1 billion was that far off. And so how do we do that? We'll use our root mean squared error. So it's nicely defined. We'll simply take the actual in 2021 minus our predicted. So we'll actually have a measure of how well this forecasting model predicted. And that brings us to the final step. Understand that this can evolve over time. So remember, we estimated the ARIMA 4.6. Maybe next time we won't even use ARIMA. Maybe next time we'll just use a theoretical regression model. Or maybe you could compare it to your manager's rule of thumb forecast. So there's a bunch of different mechanisms of forecasting. So you could use an entirely different model, or you could just use a slightly different ARMA model, or you could use the exact same ARMA model, but with more data, less data, a longer training period, a shorter training period, less memory. So you may not want to include data going all the way back to 2014 if you think there's been a structural change. So there are a lot of toggles that you can adjust on your forecast. So that's why it's an iterative process, because this is our initial forecast, but there's always room for improvement. So that brings us near to the end. And so I'm going to go ahead and I guess turn it to questions. And do you have any just questions about this quick and dirty forecasting that we've done, Charles?
No, this was really good. I'd be interested to see, like some other kind of models, how they would predict versus this. But yeah, this was interesting. That's kind of my whole thing right now. Is I know I understand the programming end of it, and I can wrangle the data all I want, but like what you do with it is what I'm having. It's kind of what I'm struggling with, or trying to learn. Um, and so these are good. These are interesting techniques, and these are the things I don't know.
Well, I'm awesome too. I'm whoops. I'm awesome. It's awesome to hear that, Charles. And I just sort of wanted to share those things with you, because a lot of these are, they're just tools see a lot of mileage. So, like the ARMA forecasting, like people in a lot of different industries use that. And, well, these are just sort of tools of economists. So that's maybe why I know them. But yeah, it's awesome to share them with you. So so let me get that formally. So you essentially are looking for new forecasting models or new data science techniques, or
I mean, I know most of them. I know most of the models and how to use them and stuff, but like I don't like these the way that you apply them to economics. Like I don't really have a good grasp of like how to apply them to real world things.
I see. Well, that's exactly what we're doing here in the Cannabis Data Science Meetup group. Is we're taking the economic theory, we're using some statistics, and we're applying that to real world cannabis data, because we're empiricists and we want to take what we're given. So remember, this all comes from, well, you remember. So this all comes from the Colorado, all these Colorado data dumps. So we're just taking this raw data. Like this is as raw as it gets. It's not even in Excel. It's just raw from PDFs, just completely raw. We're getting it into an acceptable format, is an Excel spreadsheet, like is the very least we can do. And then we're reading it in, and then we're using, modern statistics, economic theory, and we're we're applying it to try to make useful insights. We're trying to have some useful takeaways here. And so what's exciting about this is, remember, we were calculating the competitive wage over time and the historic rate of return over time. Well, now you can even forecast that forward and then apply these data points to your economic theory. So that way you can make predictions about will wages rise or fall in 2021, which is an incredibly helpful insight to people working in the cannabis industry, because knowing what the actual wage may be isn't that useful, but knowing if the wage may rise or fall, that could be vitally important to someone trying to staff their business.
Yeah, no, this is all really cool. This is the kind of stuff they don't teach you in classes. And just like dealing with these large pandas data frames, I mean, you never encounter that in a class. You never learn like these tricks.
Exactly. Then pandas is a big toolbox, so it's tough to get all the pieces.
Right, and they always give you these sort of toy problems, but these are actually like real problems using like real, real theory. Coming out with like sort of real estimates. So this is good. This is kind of the stuff this has been really helpful.
Well, that's awesome to hear, Charles. And then here in this last minute or two, I'm just going to add a time index to the data, just so we can't see if we can't just plot everything as a total revenue. There. And so now this is sort of our takeaway from today, right? So we have the historic sales going way up, and you naively may think, oh, this is just going to go on forever, but our model is smart enough that it's taken into account a little bit of this business cycle seasonality. So you have, so you're actually, as you can see, it's smooth. So it's not, a perfect forecast, but it can at least kind of give you, an idea of the path that sales may take in the coming year. So I think I'm going to go ahead and wrap it up for today. But it was a little bit of a quick and dirty exercise, so it could have been a bit cleaner. And so for next week, I may clean it up a bit and extend upon it, so that way we can do forecasts and actually apply economic theory to the forecasts. So just want to thank you for coming, and I'll be concluding it here. So see you all next week.
Okay, see you. Thanks.
All right. See you, Charles. Have an awesome day.
You too.